All right, this same example says a 5 kilogram ball is thrown vertically upward with a velocity of 20 meters per second. What is the maximum height achieved using the law of conservation of energy? Now, you could use the kinematics motion equations that we've talked about earlier, but it says specifically use the law of conservation of energy. So E1 equals E2. Now, whenever you're throwing something, you're imparting a kinetic energy to it. So to begin with, I have kinetic energy as the ball makes its way upward. When it reaches its highest point, the ball stops moving. So there is no kinetic energy in the second situation. Instead, what it has the potential to fall. So potential energy due to gravity. You notice this is the exact same thing that we did before with the rock falling and seeing how fast it hits the ground. Now we're saying, hey, we're going to throw it. We've got velocity. How high is it going to go? So we are trying to solve for h. Now, just like we had before, we have kinetic energy, which is 1/2 mv squared. We have potential energy due to gravity, which is mgh. Mass cancels out of both of those terms. So we have 1/2 velocity squared equals gravity times height. So let's look at our given information. We were given a 5 kilogram ball. Okay, that 5 kilogram ball has no relevance in this problem. G is 9.8. We are trying to solve for the height, and we were given a velocity to begin with of 20 meters per second. So we say 1/2 of 20 squared equals 9.8 h. Divide both sides by 9.8. So we say 0.5 times 20 squared divided by 9.8, and it gives us 20.4 meters is the height that the rock will go.